Greetings, welcome to day 16 of Autoforge's development. So I took the last few days off doing my daughter's birthday and just life stuff. So we're back working on the physics callbacks for Lua. So what we want to be able to do is have it so that our um, entities are able to set up some callback so that way we can have gameplay logic happening, um, reacting to our physics, like colliding and whatnot. So a very simple example is, let's say we have a conveyor belt and we want it to be able to move items whenever the item lands on top of the conveyor belt. Well, in order to do that, what we want is to have it so that we change the tangent speed of the contact so that way the item starts moving whenever they come in contact. And so that needs to happen inside of the what I call the pre-solve. Or sorry, pre-solve. Here we go. And so what I did is I made it so that we have this handle contact callback, which we can provide the pre-solve and pre-solve static, and that essentially makes it so that we say, okay, handle this contact, and we get the entities from the contacts, and if their two entities are colliding with one another, then we use the non-static version, and so they both will have the callback called if they provide that callback. So we say, hey, this entity, came in contact with you. You can react, and then we do the same with the other entity. If they both have the callbacks, maybe only one has the callback, and so we only call it for that. So what we're doing is we're looking to see if that physics component. So we get the physics component, which houses the callbacks. And that is just a list of Sol functions or Lua functions. And the other scenario is the static ones where some entity comes in contact with the static body, such as, let's say, the world tiles or something. And so in that case, we need to handle it kind of differently because there's only one entity in that case. So that's what we're doing there. And so I just call that for all of these, providing these are the different functions that are being called from the physics, box2D physics world. And then we have that handling the callback. And what that ends up looking like is something like this, where we can say, hey, whenever two entities begin a contact, we want to say that that is happening, and just like say entity 1 is contacting with entity 2, and then whenever we pre-solve the static, as meaning this pudding prefab comes in contact with, I need to get rid of these. Whenever it, there we go, that should work. Yes. Whenever this pudding comes in contact with the ground, it will set this tangent speed, which is kind of like the conveyor belt. So if I run this, unfortunately, I have to compile. Oh no. But whenever it runs, it doesn't look like it's actually going to run because I didn't test it before. But whenever it does run, it actually would log that. Sorry, I don't have that. I don't want to fix that here. Fail. But yeah, that's how it's all working. There's one huge caveat here with this system, is that we cannot change the physics body during these callbacks because we are in the middle of the physics time step. And if we were to change the physics body, that means that it might invalidate other contacts. and then we could potentially run into a crash or something. So we have to be careful about that. One thing I'm not really sure if that's something we even really need to deal with in the future, but if we do, what we can just have it do is like kind of set up some other function, which is like, hey, when we're done with this physics time step, go ahead and run, this like little callback, this other like deferred callback function that will, change the physics body, like move them to somewhere else or whatever. Yeah. And so that's it. We did a bunch of other tooling stuff and getting that all working. Maybe I'll talk about that some other time. But yeah, we'll just keep moving forward. Thanks for watching, guys. I hope you have a good New Year's, and I'll see you tomorrow. All right, take care.